Bonjour tout le monde. On va faire un petit démarrage en douceur avec une plongée internationale. Et du coup, vous n'étiez pas forcément avertis. On a cherché à mettre en place la traduction, mais là, quand je parle en français, ça fonctionne, puisque c'est une transcription et pas une traduction. Donc, l'ouverture de la journée, on va parler bien sûr de MIA-seconde, on va vous faire échanger entre vous sur votre pratique cette année sur MIA-seconde, mais en table ronde d'ouverture, on a la chance de dézoomer et d'aller très haut et très loin sur les plateformes adaptatives, donc en quoi ce type d'outil est appelé à se développer, comment ça fonctionne dans les autres pays. Et donc c'est Pierre-Yves Oudeyer, chacun je laisserai se présenter, de l'INRIA qui va animer cet échange. Et on a choisi cet horaire pour commencer, même si c'est un petit peu rude à l'heure du café de vous mettre dans un petit débat en anglais, parce qu'on joint les fuseaux horaires les plus extrêmes. On va avoir, alors, pour la France, l'OCDE, donc Mario Piacentini, donc lui il est sur place, donc ça va, le fuseau horaire, il n'y a pas trop de décalage. Mais on a Hai Siang Chia du ministère de l'Éducation à Singapour, qui est responsable de la plateforme nationale du ministère de l'Éducation à Singapour, qui s'appelle SLS, et qui est pionnier dans l'utilisation des ressources d'adaptive learning. Et on a Nathan Storey, qui est à Baltimore. On sait, you are located in Baltimore. No, where are you? Yes, Baltimore. Donc, il est de la Johns Hopkins University. Et donc là, on est de l'autre côté complètement aux États-Unis. Et là aussi, avec une expérience de quelles sont ces plateformes adaptatives, comment on s'est perçu dans ce marché américain. Voilà un petit peu la mise en bouche, si je puis dire. On va assez haut et assez loin. Et ensuite, on plongera sur le MIA-seconde que vous avez pratiqué cette année. Pierre-Yves, je te passe le micro et la parole. Et moi, j'en ai fini.
Merci beaucoup, Thierry. So we'll switch to English for this session, but only for this session. Don't be afraid. That's the warm-up. And here we'll discuss an international perspective on major current opportunities and challenges related to artificial intelligence as a potential support to education. Of course, recently everyone has been discussing about artificial intelligence and education, mostly due to the recent arrival of generative AI, who is changing a lot of things in the schools in all directions, positive, negative. But the topic of artificial intelligence in education is actually much older, for 30 years at least, and even more. There are multiple labs in the world, but also multiple educational institutions who've been working to develop, to experiment, and to evaluate a diversity of educational software powered by various forms of artificial intelligence and with various educational purposes. And so the purpose of this first discussion is to have an overview of several perspectives from diverse countries in the world on some of the current status and stakes. So we will have Hai Siang Chia, who is principal specialist at Singapore Ministry of Education, Nathan Storey, who is an education researcher at Johns Hopkins University School of Education, and Mario Piacentini, here with me, senior analyst at OECD, Directorate for Education and Skills. And myself, my name is Pierre-Yves Oudeyer, and I have two hats here. On the one hand, I am research director at INRIA, where I head a team at the crossroad of artificial intelligence, cognitive sciences, and educational sciences. And I'm also a scientific consultant with Evidence Bay, and I will be the moderator of this discussion. And so maybe let's start by you, Hai. You've been working on a very interesting system in Singapore, an adaptive platform or framework called SLS. We would be extremely interested that you explain to us what's SLS, in what context it was developed, and what is the current status of development. But and just maybe if you wish, before answering the question, you can maybe add up a little bit more about who you are, what's your background, so that everyone gets a sense of from which perspective you are talking.
Thank you, Pierre. Thanks for inviting me. Right. So my name is Hai Siang. I'm a principal specialist over at the Ministry of Education for Singapore. So I used to be a principal, and then I worked for a while with the Prime Minister's office in Singapore, and then moved back into education, working in the ministry. And back in 2018, I came back to lead an effort to build basically the Singapore Student Learning Space, which is the SLS that Pierre was talking about. It's a learning system that we give to all our students and our teachers in basically across the entire K-12. So it's a national learning system. So this was built really before Gen AI came out. It wasn't an AI system originally. It was meant more as an attack system that we wanted to use technology to kind of improve teaching and learning. It proved very helpful over the COVID period, right? We're during the pandemic, so it proved very, very helpful. And then I think while we were coming out from COVID, that's when Gen AI became a big thing, and we have introduced both traditional AI and generative AI into the system. So currently, it's being used by about 400,000 students and teachers every month. It's quite widely used for anything that is digital mediated kind of teaching and learning. So that's been very, very helpful. We have looked into how we can help our teachers better use this. It's been quite organic in terms of the growth, but there are many different ways in which we help our teachers and our students better use the system. One of which is really from the way that we design the system, right? So the system itself is an agile development platform, so we constantly improve it, constantly improve its design, not only through user feedback, but also through rapid research, what we call rapid research, right? Which tests, EdTech use against learning outcomes. And then do that over 6 to 9 months for each study, and then the findings for each of these studies actually feed back into the design of the system.
Yeah, thank you very much. Just to be even more precise, so you're saying that SLS is an adaptive platform that is available to all your students. I mean, do you mean from the primary school to the middle school to the high school, or do you have a special focus?
Yeah, it's to all the K1 to 12 students. So basically, your primary one all the way to JC2 students. Yeah, and it's also available to all the teachers. So I think about 98% of our education in Singapore is a nationally funded public school system, right? So it's available to all the students and the teachers in public schools.
And it's across which disciplines? Is this principally in mathematics, in the languages? What's the coverage?
Yeah, so it's available for all subjects, yeah, including the 3 mother tongues that we teach, which is Malay, Chinese, as well as Tamil. But also, I mean, most of our subjects are taught in English, but across all subjects, humanities, languages, maths, and science. Yeah.
Yeah, thank you very much. And so something that's always indeed a question or a challenge is what's the approach that you take in Singapore with SLS to get teachers to know the system, how to get teachers to be trained, to understand the system, to use it in the way it was designed initially? What's the approach to get teachers on board?
Yeah, so there are a few things. One, which I mentioned a little bit about, is the design of the system itself. We believe that the design of the system itself should nudge teachers and students towards good use, right? So there are a lot of explicit scaffolds that we built into the system, and the way that, for example, buttons are designed, right? Okay, the pathways are designed in terms of the system, and also today, of course, with Gen AI and also with our ALS, which we can talk about, or the adaptive learning system, which we can talk about. There is a level of intelligence inside the system which nudges students and teachers towards good instructional behavior, good teacher and learning behavior. So the second part is also, of course, to make explicit some of these principles to teachers regularly in terms of our national communications to teachers. So we have different channels of communication, different channels of professional development for our teachers. So we have a very explicit and very structured way to actually coach our teachers. And the last part is really what's organic from the ground up from the teachers. So all our teachers, about 33,000 of them, actually belong to one or more of the professional development communities that we have, right? Okay, so one of the biggest ones is on Facebook, actually, right? It's called the Singapore Learning Designers Circle. Basically, it really got very popular again over the pandemic. But in there, you have teachers that are sharing good lesson ideas, using tag, good practices. And the good thing that because we have a student learning space, they are able to reference the exact lesson that they designed, which is actually hosted inside the SLS itself, right? So other teachers can just reference the material itself, use that for their own purposes and adapt it accordingly.
Oh, thank you very much. So one of the main message, I guess, is that getting the teachers involved is really a mix between high involvement of some bodies of the Ministry of Education to inform, to train, to design the system in a way that's understandable, and also a lot of organic, bottom-up, community-based organization. That's super interesting. So we'll come back to you, Hai Siang, in the discussion, but maybe let me switch with discussing with Mario. So Mario, one of your main activities, as I understand, is you've been with your team working a lot on extending the PISA system to new assessment domains. So I'm very curious to understand a little bit what are those big new assessment domains, and also how they might relate to current developments in educational technologies. But just before also answering to that question, you might also want to add about your background and...
Yes. Bonjour. I'm going to speak in English, but I hope we are going to start a conversation afterwards and we can switch to French. I've been living in Paris over the last 17 years, always at the OECD. For the last 10 years in PISA, I guess most of you all know what PISA is, so no need for me to explain what it is. Or who knows PISA? Just raise it. Okay. Okay, so basically the main task of my team over the last 10 years, and what made my job particularly interesting was the mission of trying to extend PISA beyond the basics. So PISA, since the beginning in 2000, when we had the first survey, it didn't invent much. It was basically doing the same thing that we knew how to do in international assessment, so testing, reading, mathematics, and science. It was something that already like the IEA with teams and pairs was doing before. We just made it bigger, and we recruited more countries. We added a bit the narrative of the connection to real world, but essentially the domains were relatively traditional ones. So mathematics, la lecture, reading, and science. Of course, like there was like a lot of discussion and a lot of educators that say that, by testing only these domains, we were basically restricting the focus of education to something that is relatively restrictive. It doesn't really include all the things that you as teachers and as educators care for. So the holistic development of the students and the development of all the transversal skills that matter for the future, like critical thinking, creative thinking, collaboration skills, communication. And there is a long list of additional things that are an integral part of your work as teachers, but are kind of harder to measure. So the mission was to try to include at every PISA cycle a new domain that was trying to get into these transversal skills. It started back in 2012. I started in 2018 with an assessment of, it was called global competence. It's essentially global citizenship. So whether the students know about global issues, intercultural issues, and can relate to this kind of global problems like migration, poverty, cultural differences, climate change, this kind of big problems. Then my biggest challenge so far was 2022 when we designed an assessment of creativity or creative thinking that by definition is one of the very hard things to measure, right? How do you measure creativity? This was a big challenge. We tried to invent and innovate in the type of task we designed by creating like open-ended type of problems in which, for example, we were showing the students a picture and they had to come out with a story idea for a book with a short text. And then 2025, when we realized that we really need to use technology in a better way and try to design tasks that will really benefit from technology, essentially in one way, by programming. It was not AI, it was old type adaptive coded system. But basically the main idea is that this was a test of computational thinking, so programming, building models, that in which the students were getting feedback from the system. So whenever they started to work, whenever like they made a mistake, the system was reacting and providing feedback to that. And this is when we started really like taking advantage of technology. Now in 2029, we're developing an assessment of, guess what, media and AI literacy, because it's the hot thing right now. So yes, the work has been trying to use technology more and better to create more realistic type of experiences that are closer, that like basically designing tests that don't look like tests. So trying to go beyond the classic, stimulus, multiple choice questions, multiple choice answer, by creating activities that you as teacher would give to your students. So they look like learning activities. For example, in 25, each test unit is a 30 minutes online tutoring experience. The students learn with a tutor, they practice with a tutor. In 30 minutes, they learn to do something. And then at the end of the experience, we challenge them to show what they've learned. So the main idea has been to try to design assessment that don't look like tests, but are really learning experience from which we extract all the data that we convert all this data, all this action data into indicators and things like that. And this is where AI is really going to change things. And Matt, maybe I'll stop here and
thank you very much, Mario. And do you so as these new domains where we now understand that they are important at school and they are not part of the discipline themselves, do you believe there is a special role of educational technologies to play with these, to not only assess, but also maybe to train about these new domains? I'm wondering whether, because these are new things, we progressively understand they're really important to be taught, but we don't have yet trained fully teachers how to teach them, and maybe we don't even know how to train teachers well. We need to make a few steps. Do you believe there is a special role of technology in that context?
Yes, absolutely. I think that many teachers, most teachers, like actually do those, teach those things already. Whenever they, you work with the students, you give them like some kind of active learning activity. For example, when they have to develop some kind of projects, or they have to build something, or they have to work together to, make a poster, make a little video, all these kind of things. They research, they use critical thinking to access information, process information. They are creative because they have to produce something. They work together, so they collaborate. Most of the time they come to the class and they present their work, so they do their communication. So even in the traditional before technology space, there is a lot of that going on in the classroom. And it's really, I think it's an essential part of what education should be about, because when you get into the world of work, these are the things that everybody's asking you to do, right? So the way the technology helps is by making this experience a little bit more realistic. For example, in the science space, you use technology because maybe you don't have the tools in the classroom to conduct a real experiment. So you use a simulation in which you can play, you can simulate like an authentic world, and you can do things that, you just don't have the technology, the space. Sometimes our experiment that in real life will take a lot of time to see the results. You can simulate that. You can use virtual reality, you can use augmented reality, so you can make the experience richer and more engaging for the students. And then the other big advantage of technology is on the data collection. So basically, the main idea is that as students do these kind of activities, you try to design them so that there are like some key decisions that they need to make. And you work, when you design these things, you also try to think on the data side. What are all the decision moments that are included in this activity that can tell me something about what these particular students understand and can do, or what he struggles with? And so you try to record it. And the beauty of the machine is that they record everything. There are these big logs of data that collect everything the students do. And you have this model and this, Pierre-Yves, you know them, like all this very, very large group of researchers that are expert in analytics, in trying to convert these actions into meaningful interpretation of misconception, behavior strategies. And so it takes a lot of time, work, but at the end of the process, with technology, you as teacher can get some kind of dashboard picture of what the class as a whole was able to achieve. You get records in the forms of artifacts that can be a poster, a video, like a final product that you can store as in some kind of portfolio. And you have like the machine just helps you to interpret what the students are able to do. It doesn't replace your judgment. It just gives you some clue.
Thank you very much, Mario. And one of the recent projects is the project called PILA. Could you tell us a little bit more about what's the scope of this project? What is the status, and maybe in what countries it is being developed or evaluated?
So yes, I would share the web address of PILA so you can have a look at yourself. It's a formative assessment platform. So essentially, it's a big library of activities because, first, how it was born. It was born a few years ago when we wanted just to increase a little bit the impact of our work, because we are spending like 6-7 years to develop a PISA test. Then we were the bad thing of PISA is that nobody sees the test. No, it's secret. So we had a lot of schools that when the results came out were reaching out to us and say, okay, we actually care a lot about citizenship education. No? We care a lot about creativity. Can you help us get better, or help our students get better in this PISA metrics? And we didn't have anything to give them. So we developed this open source platform in which we started to put all the items, all the activities that we developed for PISA. And we wanted to make it public, and we started working with some countries with teachers to see how the teacher would use these activities. Now we are working nationally in some countries, nationwide in Thailand. It is a process of co-development, so we make agreements with the ministry. Then we started to develop a series of a large bank of items in one domain. For example, in computational thinking programming, we develop all these different tools, interfaces with lots of different tasks. We train the teachers. We go once a year for 1 week. We give this training, and it's a process of train the trainers. So we train some facilitators and then train the teachers in using the platform. In terms of content, yes, I think the value added is really getting into these domains that are not in the usual platform, like we have mathematics, we have science, we have reading, but we also have computational thinking, we have social problem solving, creativity, all these kind of other domains. And yes, it is growing. We have some more countries, and another key characteristic of the platform is that we always try to develop. I think we'll discuss this more. I think one of the big challenges is trying to understand what is the role of the teachers in using this platform, how we can keep the teachers active. So in PILA, what we have been trying to do is to always, whenever we create an application, we create a set of problems that we develop with the experts. So quality problems with all the metadata and all of that. But we also create these customizers. So basically, we let the teachers create other variations of the same problems using the tool. And the idea is that the teacher can use the problems that a teacher that doesn't have the time will use the problems that we provide. A teacher that wants to engage a little bit more can actually design their own task, replacing the text, replacing the problem, replacing all the elements. It's still something that we are trying to see if it works, because teachers don't have a lot of time. We have seen lots of interesting stuff coming out from teachers in Thailand and in other countries, but it's part of our reflection on how we can really work with teachers so that this type of learning platform are not just something that replace them.
Thank you very much, Mario. Very, very interesting. We'll come back to this. So maybe let's switch to Nathan Storey. So you're an education researcher in Johns Hopkins University, and so it means that maybe we can explore a little bit with you the US perspective. So one of the first question I'd like to ask you is, to what extent at this point in time educational software, intelligent tutoring systems are used in US schools? How is this organized? Is this very different in very different areas of the country? Is this decided at the district level, at the state level, at the government level? How does it work according to your perspective? And again, maybe before answering me, you can say a few words about your own background so that we understand even better your perspective.
Absolutely. Thank you for the invitation to be here today. I am a researcher and faculty member at Johns Hopkins University in our Center for Research and Reform in Education. That's part of the School of Education. And so our center works largely on third-party evaluations of education interventions, including tutoring programs and including, in some cases, AI, artificial intelligence, IPS programs. We do a lot focused on tutoring. We also have a large focus of our center that's on research dissemination. And so one of the key pieces of that is a program called Evidence for ESSA, where we are disseminating information about effective programs, those programs that have proven evidence of effectiveness in improving student learning in math, reading, social, emotional learning, attendance as well. And so some of those are AI focused, some of them are not. And we are seeing a growing body of literature and the research about these types of educational technology, IPS programs. And so it's exciting to see that grow. To your question about the US context for all these programs, the US education system is very decentralized. And so the federal government is involved and there's a lot happening and changing in the way that the U.S. government is involved. There have been efforts in the current administration to close our Department of Education and move some of the work to different federal bodies. But historically, there have been laws and policies at the federal level to guide and set out goals to lead the actual implementation in the state level, but the bulk of decision making about what is actually happening in schools happens at the state level, the district level, and at the school level. In many school districts, we kind of say that the principals run their schools like a little independent kingdom, but funding and policies typically come from the state or the district, and then the district and the schools have the freedom to determine what policies, what interventions are going to be most effective for their students. And so they take into account that they might have students that have this need or that need that lead them towards a certain type of tutoring program or a certain type of ITS program, for instance. So it's hard to say then, because of how decentralized things are, that how AI systems are happening across the country, because there's so much variation. But AI systems are being applied at all levels of education, as well as in workforce training. Personalized learning, adaptive tutoring are becoming more common. We are seeing some instances of people using AI to help with curriculum development and developing learning materials, as well as also with automated assessment and feedback. So those are all becoming more, in some cases, more integrated into the systems. There is some wariness about this, and people are trying to understand more about how this will actually implement. And our center, as I said, is one that is working on conducting third-party evaluations and hoping to share, as we find more information and evidence about these programs, help them to understand more about what is actually effective and not effective.
Yeah, so thank you very much. So indeed, your own specialization is in the evaluation of those interventions. Could you explain us briefly what are the main approaches to evaluation that you're using, and what are their pros, what are their cons, how they are used?
Absolutely. So in our center, the work that we have done focused on this type of intervention have mostly been what we call quasi-experimental studies. And those are studies that have a comparison group who do not receive the tutoring or treatment program. And so we are able to compare the students who did get that tutoring system or other intervention to students who are, we would call business as usual. And we can see how the impact of this on learning differs between students who get this added benefit and students who do not. And in general, what I have seen in the greater literature about this in the United States is that typically this is the common approach, using quasi-experimental designs. There have been a number of studies that do not have comparison groups, so they are just comparing student learning growth against amongst those students who are part of a tutoring. So they take their pre-assessment and they take an assessment from after they've been part of a program, and they see how much growth there is for those students. In the United States, there are many districts that have their own little data team, and they conduct monitoring and evaluation of programs themselves. They can run analyses, not always very complex analyses, and usually not with an experimental or quasi-experimental design where they have a comparison group. But they can see some general trends, and they can learn more from that as that goes along. Because the benefit to these quasi-experimental designs is that usually they're more palatable for schools or districts, because many schools or districts want to make sure that the students who are going to get an added intervention are the ones who need it most. So they want to have a role in identifying students who would be receiving tutoring or receiving some sort of other intervention. But and those can be very strong studies, especially when we add some elements where we're matching. But we are actually working with Evidence B to conduct what we call a randomized control trial, where the students in the different districts will be randomly assigned to be in the tutoring program or not in the tutoring program. And so the randomized control trial is what is considered to be the gold standard for for research and evaluation, because by randomizing students into these different groups, we are taking out the potential chance or bias that might be involved in a human picking this student to be tutored versus that student to be tutored. There's the research side of things where that's like gold standard. That we always try, as we go through evaluations, to add in a qualitative approach as well, where we are speaking to teachers and to tutors and to schools about the program and how it is implemented there. So we can go add into the discussion not just did this work, but what worked well for teachers and what did they think could be improved, what was going on behind the scenes that the numbers don't tell us. Another added little added component that we are looking at and seeing more of is including an analysis of cost effectiveness in our studies about tutoring in particular. And the benefit there, especially in the case of these AI and educational technology programs, is that there's promise of reaching more students in different places, in different contexts, potentially in a cost-effective way, because a tutor doesn't need to be hired in these more rural contexts or places where there might be a shortage of teachers. They have other ways of reaching those students. And so we are adding in this cost-effectiveness component to the analysis, so we can see not just did these programs work, but are they worth implementing?
Yes, very interesting. And something I'm also wondering is that when we speak about evaluation in this context, we are not actually speaking about evaluating the impact of a technological tool. We are really speaking about the impact of a whole process, and because the tool is always deployed in a particular context, in a particular manner, with particular kinds of information in a given context, and then the impact it will have will, for example, depend on the way teachers understand the tool, the way they present it to their own students, and so there is all the process accompanying the development, which are basically human processes, human information sharing, human training, community-based. So sometimes maybe the same tool, depending on the way, whether it's just dropped into a classroom with no human in the loop, no explanation, just use it, or the same tool deployed with an adequate support might have a very different impact. And so how do you address this kind of challenge?
Mm-hmm. Yeah, so those types of deployment details matter a great deal in many cases. So I referred briefly to how we would expect that there would be differences in a rural versus an urban context in terms of implementation. We also see that the dosage that students receive or their usage of a program matters a great deal in tutoring interventions. So we see so perhaps that more tutoring time occurrences during the week, each time more times per week matters, as well as tutoring over to a certain extent over a longer period of time matters. And so we see, one semester of tutoring versus 1 year tutoring can have a different effect. There is a point of diminishing returns, but we see differences in those types of deployment. We have also seen along what you're saying here, that the way these things are implemented matters a great deal. The fidelity of the implementation and implementation adequacy matters a great deal. And the training and not just the technology having this program, but the training that goes into it and the variations there can play a key role in the impact of these tutoring programs and educational technology interventions.
Thank you very much. So let me go back to Hai with the Singapore perspective. So we've been speaking about evaluation. It happens that Singapore, across a number of assessment tools, probably PISA, for example, is one of the countries with the best results. So it seems that, at least from some perspective, education is doing very well in Singapore. And so one very naive question we could ask is, in such an apparently well-performing educational systems, do we need educational technology? Why would we need educational technology? And what can be its purposes in such a context? Or maybe it means that also there are some obstacles or problems with the educational performances not reflected in some of the assessments. So I'm curious to see your perspective, Hai, on this.
Thanks for the question. So I think that there's still a lot of work that we still need to do, right? Okay, in education back in Singapore. In the cognitive space itself, where it's true that we are probably doing quite well in certain aspects in the cognitive domain, there are some new challenges, right? And some of these new challenges come about because of generative AI that is out there. We know about cognitive surrender. We know about cognitive offloading. These are new challenges that have emerged because of the arrival technology of Gen AI that I think we need to explicitly address, right? Even to kind of maintain some of the successes that we have had in the cognitive domain. And within the cognitive domain itself, of course, there are many different other aspects that I think our Singapore students don't do that well in. And these are some of the critical skills such as metacognition, critical thinking, creativity. These are things that basically I think we can do much more on, right? Okay, rather than just cognitive success, academic success within the cognitive domain. Then I think beyond the cognitive domain, there are aspects of holistic development, that we have to consider, right? The affective domain or the emotional domain, the social domains, the ethical domain. These are all aspects of education that we need to look at. And I think education technology brings certain, or rather technology, especially AI, brings certain challenges in some of these spaces, right? We know about the fact that there is relational AI that's coming out nowadays, right? Okay, that actually can damage student social development. There are things that can allow students, for example, we have sycophantic AI that basically can affect students' affective emotional development. So just addressing some of these new challenges means that we have to be a bit more explicit in using in doing certain things in schools, right, to address some of these issues. Then, of course, education technology itself, right, okay, affords some potential possibilities or ways in which we can actually enhance, that means we can even do more, right? Okay, not just to address some of these risks, some of these challenges that are emerging, but also to be able to transform the teaching and learning so that we can actually do more for our students' holistic development. Yeah.
Yeah, thank you very much for this insightful answer. And so, by the way, you just put your finger on something that maybe needs to be explicitly that the AI that we're speaking about in classical adaptive platform intelligent tutoring systems is not the same AI as the one we talk when we talk about the dangers of AI of generative AI for students, for example, cognitive surrender, the fact that they have a chatbot in their pocket and they can ask their homework to be done by the chatbot. So these are very two different kinds of technologies that were invented with very different purposes at the start. But yet we might wonder whether at some point we might find synergies in those things. In a sense, for example, we could ask how to put some generative AI components inside adaptive platform like SLS. So for example, one question, are you exploring the use of generative AI in the context of SLS?
Yeah, so in SLS, we have, as I explained before, we have the adaptive learning system, which is a traditional ITS effectively, right? So it uses traditional ITS rules for us to recommend topics, subtopics, next activity, next items. But we do that together with many of our generative AI features, right, which works in SLS as well. And these generative AI features cover some of the areas that Nathan was talking about, right? So we have in the student learning space, we have what we call the authoring co-pilot, which helps the teachers to generate lesson materials using Gen AI. We have the feedback assistance, which allows teachers to kind of mark or students to self-mark their assignments and to give feedback, right? Okay, for these assignments, we have the data assistant, which aggregates together data across multiple students and across time. And then we have the learning assistant, which is actually a student-facing chatbot with the right pedagogical and ethical guardrails that we put in place, right? Which the teachers themselves then can still customize. So these are all generative AI features that we actually utilize together with the ITS, right? Especially if like, for example, the feedback assistant is a very powerful way in which we can extend the capabilities of a traditional ITS to more open structure, less structured kind of subjects, such as the humanities, such as languages, right? Because it provides real-time and quite rigorous feedback and as well as marks, right? Okay, to student performance, right? Okay, which then allows us to use that same data to feedback into our ITS to then understand student learning states and also level of mastery. So these things work synergistically together, and you can also see that with the introduction of Gen AI, for lesson authoring, for example, right? Okay, for lesson design, right? Okay, the cost and effort that goes into content creation is reduced tremendously, right? Okay, so that allows us to start up a traditional ITS in a new space, for example, much quicker, and also to generate very interesting learning experiences, right? Okay, so learning experiences such as using the chatbots, for example, right? Okay, that kind of enrich the kind of learning experiences beyond the traditional kind of instructionist experiences that most ITSs used to have. Yeah, so these are ways in which I think the traditional ITS can work very well together with generative AI.
Thank you very much. Mario, I see you want to say something.
Yeah, I wanted to follow up also on this, on the use of Gen AI. We are also actively experimenting with that. We have two main use cases. One is on mathematics, where we created one application in which the students solve mathematics exercises with the support of a chatbot, of an AI tutor, so they can, as they see the exercise, they can ask questions to the tutor to ask clarification on what is the what should I do? Can you help me solve the exercise? And when they started solving, they get feedback from the tutor, corrections, and this is something for which we are conducting a randomized control trial. This is what Nathan referred to, the idea that try to see the effect of this AI tutoring system. It's a project that Caterina over there is doing. We are also doing it in France. So we are active. We are currently recruiting teachers. So if you're interested, let us know to try the system. It was very interesting how difficult it is to train this system. It's we have spent more than a year. The target age for this first experiment is end of école primaire, elementary school, so 5th grade students. So relatively simple mathematics exercise, and still we have seen that the AI makes a lot of mistakes, and it has been very difficult to train the AI to provide pedagogically sound feedback. Just basically instructing the AI that giving away the solution to a problem is not the right way to help a child learn mathematics, but they have to really make them think, and to try to train the AI to do as a teacher would do has been a tremendously challenging thing. We have tried to feed it with a lot of pedagogical text. An interesting thing we have been doing is that we are doing it in 5 different countries. So we have tried to feed it with different materials from different countries, also to reflect the way mathematics is so differently in the Slovak Republic, in Latvia, in France, in Germany. but it's still not perfect. And if you want to see the tool, we can show it to you, and we'll be happy to get feedback. And then, as I was saying, like we see that in terms of generative AI, the things on which we really have a lot of expectations and belief is regarding simulation for more accessing more this like creativity, design thinking, social emotional skills, empathy. So we are creating like these little games in which the students, create a little avatar, and then they go and speak with AI agents, people that we instruct to play different roles. And this is helpful because you can simulate some type of activities that will be very difficult to do in schools. For example, the students have to create a project to solve the problems of like, a big problem in Paris, anything like first thing coming to my mind, like all the streets that are full of like dogs poop. Like how do we solve this problem? So they need to speak with different people. They need to speak with the dog owner. They need to speak with the municipality. And so we can create this little scenario, and the students speak in natural language with different people, with the mayor and the things, and they can devise a plan. So on this, I think there is a lot of potential. We need to design, and we need to work a lot in, because the fact that it's a powerful tool doesn't mean that it will be effective.
Thank you very much, Mario. And let me now ask last couple of questions to Nathan, because before we have just a few minutes to let people in the room ask their own questions. So Nathan, actually, going back to evaluation. So one of the arguments that I was putting forward for the use of adaptive platforms, even in countries like Singapore, where like PISA results are excellent, is that there is a challenge at school, which is motivation, engagement in learning, pleasure of learning. And so it might be actually very important for some of those adaptive platforms that the impact that is measured is not only in terms of improvement in cognitive skills in mathematics, let's say, but it's also maybe very important to measure motivation towards learning further mathematics outside the platform, for example. Is this something that's being considered a lot right now by the scientific community working on evaluation? Is this still something to be explored? What's the status of evaluating motivation and engagement in school?
Mm-hmm. Those are great and important aspects of this all to be considering. We try and get at some of that as we do as we pair our qualitative components with our quantitative components. So we conduct the quantitative impact analysis, but then we also, as I was saying, try to incorporate surveys and focus groups or interviews with teachers, with tutors who are working with the students, and they can see and observe whether there are changes to students' motivation or engagement. It's a way for us to get past, build on our understanding of whether something works, but what is working and what is not working in an intervention. And so we can get more under the car hood to see what are the actual activities and operations of an intervention.
Okay, so thank you very much, Nathan. So the time is passing very, very fast. I just would like to know if some people in the room want to ask questions. Est-ce que des personnes parmi vous souhaitent poser des questions? Vous pouvez les poser en français et je me chargerai de les traduire.
Pas de questions de brûle.
Oui, quelque chose qui m'a frappé dans les différentes interventions, la différence que je ressens avec le système français, c'est la question des communautés, des collectivités, du collectif, qui me paraît beaucoup plus important dans ce qui nous a été présenté à Singapour ou à Baltimore que ce que nous connaissons en France.
So that's a comment. I don't know. I'm going to translate. So peut-être juste pour dire que vous êtes une enseignante.
Dianux, la FEF, c'est l'association, une des associations qui a contribué à MIA-seconde.
Ok, super, merci beaucoup. A question from someone representing an association of teachers working around the development of MIA-seconde. And so, in what I described in Singapore or Nathan in the US, there is a very important role of the community, of the collective, of teachers, of bottom-up organization. And it seems that it is something that's not that's very different to what's happening in France, where for multiple reasons there is a lot of dynamic that come from the top, and maybe a little bit I don't know what are the different causes, but a little bit less organic possibilities from the base. Do you have any comment or suggestion on how to foster this kind of organic involvement of teachers in various contexts?
Yeah, maybe I can answer that very quickly. So one of the things that we always try to explain to the developers that are working with us, and also to education technology companies, is the fact that the development of education technology is a little bit different from the development of any other productive technology, right? Even if fundamentally they might use the same underlying generative AI, things like that. And I think one of the biggest differences, which we all understand as educators, is the fact that education technology is like delivering medicine, right? In the sense that it requires there to be certain deliberate frictions that we introduce in the platform, which results in productive struggle, which leads to learning. Yeah. And so what I'm trying to say is that teachers play a very important role in ensuring that happens, especially for younger students, right? It is like saying that you have young children that will take medicine without the doctor, or without a parent that's forcing them to, or at least encouraging them to take medicine. So the problem of understanding the difference, right, between the education technology development and the nature of education technology that's designed for learning is versus other kinds of technologies is super important, right? And that is where I think the teachers and educators and education researchers play a very, very important role. So what I would start with is really trying to get that across, right, to the entire fraternity, to the folks that are developing technologies, right, the companies that are developing technologies, to make them a little bit more enlightened, including, of course, also government, right? Because the senior policy decision makers at the top might not understand the differences, right? They might go in and use a productivity tool on Microsoft or Google and expect that the same kinds of philosophy and principle can be applied to education technology, which it cannot be done, right? So understanding that basic principle, I think, is super important. And once you have that, then I think the importance of educators, of teachers, and teachers' involvement becomes super important.
Thank you very much. Est-ce qu'on a une autre question?
Bonjour, Christian Jacubels, proviseur adjoint de lycée Jeanne Barré. Moi j'avais une question justement par rapport à Mario qui disait qu'on avait plein de modes d'éducation dans le monde. Et en fait, moi je me posais la question sur le fait d'être comme ça sur des plateformes d'e-learning, si finalement il n'y avait pas parfois en fait une illusion de compétence des élèves, des étudiants. Et si on ne ressentait pas justement cette illusion de compétence quand il y a de nouveau un passage à l'écrit. C'est vrai qu'on est quand même dans une école où à la fin, et là on a les résultats du bac aujourd'hui, on doit quand même finalement composer à l'écrit. Est-ce que justement il y a des moyens de mesure? Je sais que pour PISA par exemple, autant en France on va le passer sur des plateformes numériques, autant dans certains pays d'Afrique, d'autres pays de l'OCDE, ça va être plutôt à l'écrit il me semble, parce qu'ils n'ont pas toujours de technologies adaptées. Donc voilà, j'aimerais savoir quel est votre sentiment là-dessus.
Thank you very much. I'm going to translate. So that's a question about the fact that when students face a digital learning environment, because it's digital, they might have an illusion of competence, maybe because in general, when they use digital tools, they feel competent. And it might mislead their learning within the tool, but also mislead the self-evaluation of their competence outside the tool when they go back to a writing exam, for example. And so I guess this relates actually to the development of metacognition, which relates to some of the further domains that you were exploring, Mario.
Yeah, it's a very good question, and I think one of the issues of technology is that, especially in the test assessment world, is that we are mostly like using technology for like saving money, and the way you use technology for saving money is through multiplying the multiple choice type of items, because these are automatically scored, are very reliable, and so in this process, like technology has strengthened a process that was already ongoing when they invented these machines to process the responses to multiple choices. That is a deviation towards like this world in which you don't really need to produce anything. You just need to show that you understand something and check your understanding. There is a lot that can be done in the multiple choice world. I'm not against my specialization is assessment. I still use a lot of multiple choice, but I really think we need to diversify the output and trying to use technology to get into more creative type of production things. Even in mathematics, there is a lot that can be learned by having students actually like work out and writing down the steps in a problem. I've been pushing a lot, trying to push a lot for having some kind of tablet machine in which the students could actually write and work out the reasoning. It's an additional cost, so I'm still trying to push for it, because yes, for example, one of the I think the PISA test was more informative when it was still on paper, because we were receiving, for example, as a researcher, one of the first PISA report I worked on, I asked it to receive the paper of the that the students were using before inputting their responses in the QCM. And there you could see a lot about the reasoning, a lot about the writing, a lot about these things. So I think we have to push a little bit on the technology frontier to try to use writing pad and general AI tools in which the students can write extended, because again the power of technology is in the data, and if we restrict to only multiple choice, we are not really looking into the mind of the students. We will never be able to really understand all the things that students have in their mind, but we need to enlarge our loop, our capacity to look inside, and that's. I think we just need to push technology to do a bit more on that.
Okay, thank you very much. There would be so many more questions to ask to you three, but the time is now to get to the next session. So thank you very much again, Nathan, Hai, and Mario.